Welcome to part 2 of the Agentic AI training series, Building AI Agents. This part covers prompt engineering, memory systems, RAG architecture, and includes hands-on projects to solidify your learning. This video is divided into 4 modules. Module 5 focuses on prompt engineering techniques. Module 6 dives into agent memory systems, covering short-term and long-term memory, vector databases, and semantic search. Module 7 explores Retrieval-Augmented Generation, and Module 8 is a hands-on project to build various AI agents. We begin with Module 5, Prompt Engineering for Agents. This module explores how to structure inputs to guide AI behavior effectively, covering system prompts, role-based prompting, chain of thought, ReACT, and structured outputs. A system prompt is the agent's foundation, defining its persona, objective, constraints, format, and context. A well-crafted system prompt dramatically improves consistency and reduces hallucinations. Think of it as the agent's DNA. Role-based prompting gives your agent an expert identity, activating domain-specific training patterns for better performance. The anatomy of a role prompt includes defining identity, expertise, communication style, scope, behavior, and constraints. Chain of thought, or COT, prompting teaches agents to reason step-by-step before answering. This significantly improves accuracy on complex tasks. Techniques include zero-shot, few-shot, auto-COT, and tree of thought. The ReACT framework is a core engine for modern AI agents interleaving reasoning and acting. The agent continually cycles through thought, action, and observation until the final answer is reached. This enables complex task completion through tool use. Structured outputs force AI to respond in machine-readable formats like JSON, YAML, or through function calls. This enables reliable parsing by downstream code, eliminating hallucinated field names, and is critical for agent tool calling pipelines. Next is Module 6, Agent Memory Systems. We explore how agents retain knowledge across conversations and sessions, covering short-term and long-term memory, vector databases, and semantic search. Short-term memory is volatile, immediate, and token-bound by the model's context window. The entire conversation history is sent with every API call, which can impact cost. Older messages are truncated when the context limit is reached. Long-term memory provides persistent knowledge across sessions. It encompasses episodic memory for past interactions, semantic memory for facts and concepts, procedural memory for workflows, and a declarative store for explicit data. Various storage backends support these systems. Vector databases are the backbone of semantic memory. They store data as high-dimensional numerical vectors, enabling similarity-based search rather than keyword matching. This allows finding semantically related content, improving retrieval accuracy. Embeddings convert meaning into mathematics. Text is transformed into a dense numerical vector, capturing its semantic meaning. Similar meanings result in similar vectors, enabling analogical reasoning and multilingual capabilities. The dimensionality varies by model. Semantic search finds meaning, not just keywords. Unlike traditional keyword search that relies on exact word matches, semantic search understands the intent of a query. This ensures all relevant documents are found, improving the quality of the results. Module 7 covers Retrieval-Augmented Generation, or RAG. This technique is critical for grounding LLMs in external knowledge sources to reduce hallucinations and ensure answers are current and factually correct. RAG solves the hallucination problem by fetching real, up-to-date information before the LLM generates an answer. The RAG process involves retrieving relevant data chunks, augmenting the LLM prompt with this context, and then generating a grounded response. It's ideal for company knowledge bases and real-time data Q&A. RAG architecture uses 2 pipelines: indexing, which is offline, and retrieval, which is online. The indexing pipeline takes documents, chunks them, embeds the chunks, and stores them in a vector DB. The retrieval pipeline takes a user query, embeds it, searches the vector DB, augments the LLM prompt, and generates the final answer. Document processing is a crucial first step for RAG quality. It involves 6 steps: ingestion, parsing raw files, cleaning text, adding crucial metadata for filtering, chunking into optimal segments, and a quality gate to filter out bad segments. The size and coherence of your chunks heavily influence RAG quality. We explored strategies like fixed size, sentence-based, and the commonly used recursive splitter. Advanced methods include semantic chunking and agentic chunking, which use the LLM to decide split points for higher quality context. Vector search finds similar chunks using mathematical similarity metrics. Cosine similarity is the default for text embeddings, measuring the angle between vectors. Dot product is faster when vectors are normalized. Approximate nearest neighbor algorithms like HNSW, IVF, FAISS, and ANNOY enable fast search across massive datasets. To optimize RAG, use advanced techniques such as hybrid search, which combines dense and sparse methods. Re-ranking improves precision by using a cross-encoder. Query expansion reformulates the query to increase recall. Other methods include contextual compression, self-RAG, hide, and the recursive abstractive processing technique, Raptor. We now transition to Module 8, Hands-on Projects. Here, we apply all the knowledge from the previous modules to build practical, real-world AI agents like a knowledge assistant, a PDF chatbot, and an enterprise documentation agent. The Knowledge Assistant project guides you through building a functional RAG system from scratch using Python, LangChain, and ChromaDB. We cover all 6 essential components, from document loading and indexing to the retrieval chain, generation layer, memory, and a Streamlit UI. The PDF Chatbot project is a deep dive into building a conversational AI capable of querying any PDF document. This involves an 8-step pipeline, from PyMu PDF loading and semantic chunking to vector storage in Chroma and running the conversational retrieval chain. The company documentation agent focuses on enterprise requirements. This complex agent supports multi-source data ingestion, namespace-isolated indexing, and robust security features like PII redaction and role-based access control. We also integrate it with platforms like MS Teams and build an analytics dashboard. Testing and evaluation is vital for systematic improvement. We use the RAGAS framework's 4 metrics: faithfulness, answer relevancy, context precision, and context recall. Testing includes unit tests, end-to-end tests with a golden Q&A dataset, adversarial tests, and load testing for performance benchmarks. You've successfully completed Part 2, Mastering Prompt Engineering, Memory Systems, RAG, and Hands-on Project Development. Join us next for Part 3, Deploying AI Agents to Production, where we cover MLOps, cloud, and DevOps essentials.